In this video, I'm going to show you how to add a color bar and a legend to an Earth engine image, and you can show them on the map. So in the previous videos, I already show you how to, for example, visualize Earth engine image and how to get some metadata and also do some mathematical operations. But sometimes if you have some data on the map, if you want to show to other people, it will be useful to add a color bar for continuous data set. For example, if this elevation, you might want to show a color bar to indicate the color. Is it high elevation, low elevation? Also, what kind of a range of the elevation? If it is some kind of a lane cover dataset, semantic dataset, you might want to show, for example, for each color represent what kind of a lane cover type. So this is what we are going to cover in this video. First, let's go to the website to download the notebook example, tutorials.gmap.org, and then image color bar. And then just click the upper right corner, download the notebook. You can download it to your computer anywhere you like. Hit save. Once it's downloaded, then you can open Anaconda prompt. Just type conda activate GE, our conda environment, and then just type Jupyter notebook. Hit enter. Then navigate to the directory GE and just open image color bar. This notebook has 3 sections, so color map and color bar, and the last one is a legend. So you can, if you want to see the table content, you can navigate through. So first, we're going to go through step by step. Make sure that you install the Gmap, and then you can import the libraries. Once you have the libraries, then keep in mind here we have a new module called color maps, and we import the color map as CM. So this is basically it stands for this long module, and so CM represent this one. So in that way, you don't have to type the entire this lengthy name. So you can just use CM. Once you have this, we can the CM is a module. So this module has a dictionary. So this one basically is being under this module. And so let me just add a new cell in here. So you just type CM dot and then hit tab on your keyboard. So once you hit tab, you should be able to see the list. And here we're going to use the palettes, right? So the palette basically is a dictionary, has all kinds of palettes, and then just dot again, hit tab again. You should be able to see the entire list. So this is all the available color maps for Gmap, and they all come from the Matplotlib library. So Matplotlib is a protein library for, very popular in the Python community, and so you are welcome to, for example, select and then just let me hit that again, and then use your keyboard up and down to select any one you like. And once you hit enter, you can alt enter to execute. So this one shows you here all the palette. So it's basically a tuple, and from by default it's going to depend on how many each type you might have different colors. So this will be useful because if we need to visualize Earth engine image, sometimes you need to have a palette, and it might be difficult to remember like all the colors for the palette, and depends on the dataset you are using. Sometimes it can get quite complicated. So using this palettes module, we can easily get all kinds of palettes without having to remember them. So for example, we can there's a couple of common ones that we using in Google's engine. For example, DEM, NDVI, and NDWI. If you want to, for example, just get a palette, you can see. So let me show you in here, palettes, and then dot, and you hit tab, DEM, right? Just type one character. You don't have to remember exactly, and just hit enter, alt enter, then you execute. So this is the palette we can use for visualizing terrain dataset. And you can also have the other one, NDVI. So again, shift enter, right? This one gets a bit longer. Just keep it in mind. So the palette, you can have a large number of colors. So this is right now only 5, and for the NDVI you have more. You can also have NDWI, normalized water index. So this basically the number of colors varies, and some of them you have a pound sign, some of them don't. It doesn't matter. So the Gmap package can automatically handle whether it has a pound sign or not. Also, you can, for example, if you want to get the palette, besides this, you can also just use this one, CM get palette. You can also specify how many classes you want, because in Matplotlib most of those are continuous. So basically, you can get an unlimited number of classes, so unlimited number of palettes. And for this case, we're gonna get 8, but you can get more if you want. So if you just hit Shift Enter, you should be able to get, for example, if you want 8 color, you want to get 8 color. You can change to, for example, 12. You're going to get 12 color. So this is basically interpretation of the color. Maybe let me show you this one. You will be more clear. Like, what do I mean? Okay, so you can also use the cm.plot color map, and all you need to just provide a string. So this string here is earlier I show you, like it has all come from the palette libraries, like cm.palettes dot, right? So from here, all the things here in this list, you can actually plot it, right? So if you scroll down, you should be able to find the one named terrain. So right, so in here terrain, or it can be like terrain R, but RB means reverse, like reverse the color. So if you just plot this one, and then you can set, for example, the width and the height. The width is this, the width inch, a centimeter, and then from this one here it's 0.4. Also the orientation, right? So is it horizontal or vertical? So this is where you can control. For example, if I change to terrain R, it's going to reverse the color, right? So if you see closely, right, the blue right now is on the right, means high elevation, but if you do the original one, it's on the left side. So this is give you a way to plot the color map. Later I'm going to add this to the map. Okay, you can also change the orientation, right? So by default it's horizontal, you can change it to vertical, right? If it, but if it's vertical, you also need to switch this one. So for example, the width, it might be narrower, so you be switch these two numbers. So this one becomes 0.4, and the other one, the height becomes you can 8 or whatever number you want, right? Now it becomes vertical. So this is how you can plot the color map, right? But usually by default we're going to use this horizontal, it'll be enough. And this is just for one. If you already know a specific one, you can just this, right? I can change the other one. For example, the other one might be GS this, and then I think it's Earth, right? Or not this one. So let me take a look at G or GIST. This one here. If you provide one column map does not exist, you're gonna get the error messages, right? So this is the one in here that we do. And so you can also plot all the color maps all at once. For example, cm.list of color maps. This one is going to show you all the colors, all the available options, right? And it has, I think, almost 170 colors. So this is a lot for you to choose from. But these are all just a string, just a name. It might be difficult to imagine like what the color look like. So if you want, you can actually plot all the color maps all at once, and you can set the width and height. I'm just going to execute this one just to show you what kind of options you can have. So anything that's being shown in here, you can use this to visualize Earth engine image for any like single band Earth engine image, right? So these are pretty nice. And if you go through, some of those are discrete, but most of those color maps are actually continuous. So this color, basically you can get unlimited color from this one, and you can also specify how many classes you want. So for example, if it like specify like 3 or 4 classes, it's going to subdivide this evenly into different subsections, and then just get the color in between. If you scroll down, there are lots of colors you can choose from, right? So from terrain, and some of those are common ones that we can use to visualize data. So and when you're trying to visualize the data, you can just plot all the color maps and choose the one you like. And once you know the name, you need to figure out what's the name for that color map. Once you know the name, then we can continue to the next step to add the color bar. So next, let me continue in here. And this time I'm going to show you here, just use the elevation dataset. This is the USGS global DM 30-meter resolution, and we're trying to visualize. So keep it in mind, here we use the cm.palettes.dm, right? The one I showed you earlier. And then everything else is pretty much very similar to what we did before. You add the layer to the map, and then you pass in the visualization parameters. So the last one here is to add the color bar. So the color bar, if you want to see the options you can have, you can shift tab on your keyboard to bring up. Oh, you might need to execute first. Just execute. Let's see the result first, right? So this one here, this is the elevation and global DM, and add the layer. So the color bar here, shift tab again. You can click the plus sign. You will see here we have a bunch of color that you can customize. So the first one here is the visualization parameters, and also the C map is basically the color map, whether it's discrete or continuous. You can also have the label and also the orientation, right? Vertical, also the position where you want to put on the map, also whether you want or not want the background to be transparent, right? And also the name of the layer. If you set the layer name, the color bar is going to be linked to the layer. So if you turn the layer off, the color bar will also be off, right? So if you see from this one here, and this is the recommended because otherwise you have too many color bars. Once it's added, it will be always be layer if you don't link to a layer name. So you cannot really turn that one off. It gets more complicated. So you always want to have a layer name, because the layer name comes from here. This is the layer that we added, the DM, and then we link the color bar to this DM so that it can be turned on and off along with the DM. And you can also turn the opacity if you want. So this is how you can control the layer. And this looks pretty nice, right? Now you can clearly see the elevation range from 0 to all the way to 4,000 meters, right? So white color here represent higher elevation, right? Green color represent lower elevation. So clearly along the coastal area, those are all low elevation area, and these are all the mountains actually represent high elevation. You can zoom in to see more details if you want. Okay, so this is how easy it is that you can add a legend to the map. All you need is just basically the visualization parameters. So the one that you use to visualize the map is the one that you can pass in to add a color bar. So the color bar automatically come from here, come from this color palette, but also the minimum and maximum, right? So the minimum and maximum is the one from here and to here. You can certainly control this one. Like you can set to maybe 5,000, 6,000, or whatever you want. The color bar is going to automatically adjust to this one that you're using. So for example, if I click this one again, you should be able to see now it adjusts to 5,000, right? So it automatically based on this one. So depends on the data set. This one can always be different depends on the data set you are using. Okay, so this is how you can add a default color bar, but there are more options you can choose. You can also, for example, you can make vertical, right? So if you add another one, if you have the layer name the same, it's going to replace the existing color bar. So let's execute this one and see what happened, right? So now it changed to vertical because we changed the orientation to vertical. You can also have the background to be transparent. So right now we have a white background for the legend, but if you set the parameter transparent BG means the background equal to true, then it's going to take out the what happened? Interesting. It's supposed probably maybe because I didn't update the IPy leaflet. So this one here, the transparent, I need the IPy leaflet version need to be a little bit higher. I believe the version that I have is probably lower. So let me double check. Okay, conda activate GE and then conda list. I believe the we need Python 3. IPy leaflet 0.13.4 or something. Let me show you here. IPy leaflet. Okay, yeah. So 0.13. We need 0.4. So this one right now the version is a bit low. If we want, we can actually update the package. So let me show you in here. to update the package. So just pip install and then hyphen upgrade and then ipyleaflet. It's automatically install the latest version. So 0.1306, and now we can once you install, you need to restart the kernel to take effect, otherwise you won't be able to see this result. So let me restart the kernel, and then I can just put something in here, cell run all above. So it's going to run all of them one more time, and then we can get to this one to see the map. Oh, do we have some error? Okay, so this one here, you can just delete, and let me do it one more time, cell run all above. Okay, so almost there, waiting for this one to be executed. Okay, so now we still have this one, and then we're going to do it again, convert this one to vertical and run this one. So I expect this one to be transparent. Still not transparent. That's weird. Anyway, I tested on my Linux computer. It works fine, but this is probably just the Jupyter Notebook issue. Sometimes it takes a while to actually to update, and I'm gonna try one last time. If it doesn't work, then we just skip this one. Yeah, color map, then if it works. Looks like still not working. Anyway, next, let's just skip this one. If you have a newer version of ipyleaflet, you should be able to see this one transparent. And the next one here is that you can also change this one to discrete, but it doesn't really match what we are doing in here, because the DM here, this one is not discrete. But I'm just showing you that you can do that if you want. You can discrete the color bar to different sections. So this is especially good if you indeed your dataset is discrete. But when you have discrete, actually this one belongs to the legend, and this is why we want to introduce the next portion, how to add the legend here to the map to represent the color of your image. And so the legend here, Gmap has a couple of built-in legends. So basically you just need, if you want, you can take a look at this. Let me just run and see some of these are built-in. There are not many, just a couple of those. But some of the common ones, for example, NLCD and NWI, National Wetlands Inventory. And we're going to try out these two just to show you what it looks like. Okay, so first we're going to add create a layer, create a map, and then we're going to change the base map to a hybrid, basically Google satellites with labels. And then we add the base map, for example, National Fish and Wildlife Service NWI Wetlands raster. Then we add the legend. So the legend here, we have this one, the parameters called built-in legend. So the built-in, basically you can pass in any of those here to this one. You should be able to see the legend. So just execute. Okay, this is what it looks like. So this one is the legend here, the built-in one. And you can click here to turn the layer on and off. Keep that in mind, because the built-in, the legend is not tied to any layer. So when you turn the layer off, the legend will still be on. So this is the downside of using the built-in. I'm going to show you the other way later, but right now you can see this one, right? You can turn the layer. The layer is supposed to be off. Doesn't work. Let me see here. There might be some bug that I need to check. Anyway, so if you zoom in to any location, you should be able to see, for example, the wetlands or lakes or surface water here in this region, right? And we can correspond to the color. For example, fresh water. These are basically lakes, right? This one here, and so this one color here, fresh immersion wetlands, and some other types depending on the location that you are looking at. You can also fresh water pond. And this is how easy it is, right? You can add the layer base map, and then you can add the legend. So, and the user will be able to understand what each color represent, what are the features of those represent. For example, this is a river line, right? So from here, this one is for wetlands. Similarly, you can do that for national wetlands national land cover database, for example 2016. And similarly, you can add the built-in legend NLCD. You will be able to see the color, right? And this is the same idea. You have this one has a lot more classes, so you can each color also has a value. But again, you can zoom in and you can take a look. You can also correspond this one to the color on the legend here, right? So red color represent developed area, and so this one brown color represent cultivated crop or something, right? Cultivated crops. And so different color each color represent one land cover type, and you can use this one to show the users like what this one represent. This is particularly important if you want to publish this map. Although we are not going to show you here in this course, but you can actually publish the map to the web, and then anyone can actually visualize the dataset if you want. But this is just showing a way that you can add a legend here to the map. Lastly, I'm going to show you the other way that is a lot more flexible because not all the legend that you want to add can be found here on the built-in one. So you can also build your customer legend if you want. All we need basically is just a dictionary, right? So we create a map and then we create a dictionary. So the dictionary basically you have a key and also a value. So it's a list of key and value pairs, right? So if you have a key, you have a value. And let me look at this one here. So the key is basically is the text, and the color is this one. So it represents the color. And you're gonna have a list of this. And once you have this, you can add Earth engine image, right? So this is the Earth engine image from the NLCD land cover, and then you add the layer to the map. Once you add the layer, then we can add the legend. So the title, you can change the title, but you can also pass in a legend dictionary. So the legend dictionary comes from this one that we define here, and also we type this one to a layer name. Just hit execute, and let's see what happens. So this one essentially is the same as this one, but keep that in mind. This one here, the base map, this NLCD, this one is not Earth engine data. So this is just a web service that from the USGS, and it's a web service. Once it's a web service, you cannot actually get the values. But Earth engine data, you can actually get the value. So for example, if you click here, use the inspector, you click on the map, you're not going to get the value because this is just like already being transferred to your computer as a JPEG. You cannot actually get the pixel values. For Earth engine data, you can. So if you click this one and then you click on the map, you will be able to get the pixel values, right? So if I change, right, you should be able to see the color. For example, 41, and then you can come back to the legend here, decidual forest, and for example, this will be agriculture, 82, right? And you can also click somewhere near the urban, 22, develop low intensity. And so this one is a lot more flexible because the data is still interactive. You can this is Earth engine data set, and you can add the legend. Also, I like mentioned earlier, if you use this way, you can, the layer the legend is linked to this one, so you can turn it on and off. You can also change the layer opacity. So for example, in here, turn it on and off. You can also change the if you want the different base map, you can zoom in and then full screen. You can change the base map if you want, right? So click this one here, and then you can change the base map to maybe to hybrid, right? And now you can actually overlay the land cover on the right. To give you more detailed information, if you want to overlay the land cover with the satellite imagery, you can. So this is how you can validate the dataset whether it is the accuracy of the land cover dataset. Okay, so you're welcome to customize this. All you need to do is just to change the list of the dictionary, right? You can change the key, you can change the color. So once you have this, then you're going to create a different kind of legends in here, depends on the dataset you want. And this give you a quick way to add something, make your data looks more meaningful or more useful and easier to understand if you have a legend or a colorbar. So the legend is for discrete data, like the image pixel values are integers, And the color bar that I showed you earlier, that one is for continuous data set. So if your data set is continuous, then you can add a color bar. And these are basically the two different types of image that we are dealing with frequently. So depends on the data set you are using, you can either add a color bar or add a legend. Okay, so that's all for this video. Hope to see you in the next one. Take care. Bye bye.